Right, so hello everyone, and welcome to my talk, which is called From Bugs to Brilliance, Testing Toolbox in Action. Make sure you scan this QR code here, which leads you to the Slido. You probably know this already by now. Make sure you select the cinema number 5 so that you ask the questions in the right place. And feel free to write down questions at any point whenever you feel like you have a question. And I will make sure to leave some space at the end so that we can tackle them together. So I want to quickly introduce myself. My name is François Martin. I'm a senior full-stack software engineer, and I work at Karakun. And I'm also an active member of the Swiss Testing Board, where we drive forward standards in testing. And I'm also a co-author of 2 of the syllabi, one of which is the advanced level test analyst, and also an upcoming syllabus, which is the software security test analyst. And also, by the way, we have a booth at Karakun here, and you can get some Basler Leckerli, which is like a Swiss specialty. So make sure you go to the booth and check it out. And also, by the way, I hope you brought your toolboxes. So unfortunately, I was only traveling with hand luggage, so I couldn't bring my literal toolbox with me. This is why I 3D printed a little tiny toolbox, because that fit into my luggage pretty easily. Since it's probably difficult to see, here you have a picture as well. And you also get the QR code here to get all of the code for all of the demos that I'm about to show. And I'm also giving away this little toolbox at the end of the talk. So, the first person that kind of approaches me can have it. You can also use it as a makeshift phone stand if you have a small phone, which is something an attendee figured out yesterday, which is kind of cool. And you also have the link, the short link on it to go to the tools. So I will not be able to show all of the demos that I've prepared. This is why I'm also giving you access to the code, because then you can have a look at all of the different demos that I prepared. So you can look at the ones that you're also maybe interested in. And also this allows you to try out all of the demos that I've shown you today and replicate them on your own. So I'll leave you some more time to scan the QR code, and then afterwards I will start to dive into the code. All right. So let's see. So first, let me do a quick question. So do you all see what is written on the text? Last row, maybe give me a thumbs up. OK, great. Thank you so much. Perfect. Good. So maybe let me do a quick poll to figure out kind of like what my audience is here. So who of you writes Java code? Raise your hand. OK, that's practically everybody. That's great. Who of you writes JavaScript code? OK, I would say like half of you. Nice too. That's great. And who of you would say, your position is a developer where you're working? OK, that's most of you. Perfect. Great. Thank you so much. So I think I'm going to first focus on some JUnit-focused tools that you can use to extend JUnit to make it even better. So I'm pretty sure, like, who of you has used JUnit before? Yeah, that's practically everyone, right? Yeah, perfect. So who of you knows SRJ? OK, that's already almost everybody. So for those that don't know it, I'm just going to quickly show you, but I'm not going to dive into too much detail. I have a simple example here where I have a record of a person and I have a person repository, just like you would have in your application maybe. And I have a function called getPeopleBornIn. And I have here just a stream which filters the people by a city of birth, which you can pass in as a parameter. And then I give this back as a list. And normally, to be able to test this in a way that is really maintainable and explicit, it's kind of difficult. But you can do it quite easily with SRJ. So the way you can do this is, here in this case, what I'm doing is I create a new person repository. I call getPeopleBornIn, for example, with Las Vegas as the parameter. And here in the then, what characterizes SRJ is this assert that keyword. Here you can pass in something on which you want to perform some assertions. Then you kind of have like this chaining or fluent API, as it's called sometimes. And then we can say we want to extract the first name and the last name of each person. And then we want to say that we want to verify that the list that we got here as a result contains exactly in any order, because maybe we don't really care about the order, these values, so James Smith, Mary Miller. And just to see if that worked out, let's run the test. And oh, something went wrong. So let's have a look. And we can see here it says it failed. And what is also nice is the error output of SRJ. And it's one of the reasons why I mostly use SRJ whenever I can. So you can see here, for example, it says expecting actual James Smith, Mary Miller, to contain exactly in any order James Smith, Mary Miller. And it tells you elements not found are James Smith, and elements not expected are James Smith. So you see here there's an H missing. And you can see in the actual it's missing too. So now I know, okay, so probably the reason that this is failing is because we have a mistake here. So let me add here an H. I made just a typo. And now the test passes. So you can see this is really powerful. Probably most of you have experienced the case before where it just says, expected true but was false. Who of you had a case like this where it was really, not really useful? Yeah, exactly. So this really helps with this issue. You will get a meaningful output, which helps you to really make sure that you understand very quickly what the bug is, and you're able to debug the issue very quickly. So then let's have a look what we have else. Who of you makes REST API calls? Okay, almost everybody of you. I expected that. And who of you uses availability or knows it? Okay, not that many of you. So let me show it to you. This is kind of a tool that allows you to do integration testing with, for example, if you have a Spring Boot application or a Jakarta E application, one where you have a REST API and you want to test it. And you can see here is an asynchronous service. I just to have like an example made here a simple async service, which when adds data is called, simulates a delay. This would be just like if your application was saving the data to the database or like fetching data. So this kind of simulates that by having just a 2-second delay here. And then we add it to a list that we have here. And we can get the data here from the list. So pretty simple. So normally if you would write a test and you would call add data here, and then you would afterwards call get data, you would have the problem that when you try to assert, it would tell you the element isn't in the list of data, because usually the call of add data, which happens asynchronously, will not finish before get data is called to verify the assertion. And availability is just the right tool to allow you to fix that or to make sure you can still test that. And you can see that here. So here you can see I create a new instance of the async service, and then I define, or I get the data here. I have a string hello availability, which I then call add data with. And then here you can see we have availability.await. This is kind of the syntax that you use always with availability. And then you have here at most with, for example, 5 seconds. This is the maximum time that you want to allow for it to wait. You can define this as long as you want. But what it does is we have this function here until asserted. And whatever we pass here in this lambda, it will continually retry calling that until it is satisfied. And if it isn't satisfied, then it will wait for 5 seconds max. And if that still doesn't satisfy it, it will then fail the test. So we can now run the test and see what happens. And you can see it's already passed. So we have here build successful. And just to prove you that, if we change something up here, let's say we change this now to 6 seconds in terms of the delay, and we rerun it again. You can see the test fails because we defined that we want to have a time of 5 seconds here, and we exceeded that time window, and that's why the test is failing. So this is a really nice way of doing this. And by the way, if you want to do the demos on your own, every of the demo folders has one README file which exactly explains to you what requirements you have for this, and also where you can find the documentation and how you can reproduce running those tests on your own. And this way you can really easily figure out how to do it yourself. So good. So we have availability find out, and then who of you has struggled in the past with setting up test data where you have like complex objects that are big and so on? Okay, so practically every one of you. Yeah, that's a very common problem. So let me ask, who of you knows Data Faker? Okay, not that many of you. So this is a very useful library. It allows you essentially to define how you want to fake certain test data, which is why the name data faker comes from. So again, we have like a record here that could represent an entity that you're saving to your database. And then we have a repository to save them. And we have an employee as well. And you can see the company has a list of employees. And if you have written tests in the past where you wanted to test creating a company, you know how painful it is having to create like multiple different employees and so on. And this is where Data Faker helps us out a lot. So I really recommend you to use it in a factory pattern. This is not something you have to do, but it's something I recommend you to do just to make it a bit neater. So here, what you can do is you have this faker instance, which is from Data Faker, and then you can create a method like here, generate random company, where you can define, when you call the constructor here, for example, that you have here an ID, and you can say faker dot, and then the type of data that you're looking for. Like in this case, we have ID number, which is what I'm looking for. And then here you can say company name, company industry, company, and then address, full address. And then it will fake data automatically for you, and it will randomly generate like an address that looks somewhat legit. It is obviously not legit, but you know it looks like one. So this could be also really useful to make sure that the data is kind of looking accurately to how it could be in production as well. And there are a lot of different things. So if you look here, for example, you could also say we want the building number, we want the city name, whatever. You know, there's tons of things you can choose. And then we have a method here where we generate random employees, where we can then define the employees here in a similar way. And then in the test itself, we can then just call on the company factory, get random company. We can, for example, pass the amount of employees here. And then this way, when we call repo.add, we can then check when we get the employees from the repo if the company that we are getting is correctly formatted, for example. And this might seem like a lot of work still. So if you were wondering, is there maybe an even easier solution than that? The answer is actually yes. So there's a library, it's called Instancio. Who of you has heard of Instancio before? No one. Okay, that's cool. So that's perfect because I always like if everyone in the audience can learn at least one new thing. So now you learn at least one new thing with this library, which I recently discovered, and it's really cool. What it does is we have the same classes as before. However, what you see here is we don't have a factory class, and we have only the company repository test. And the cool thing about Instancio is you just call .create, you pass in the class reference that you want to create test data for, and it does everything for you. It sounds like magic, but it works really well. Like if I run this test, for example, now in debug mode, just to show you what kind of attributes there are, you can see here we have the repo, which has now in the beginning a size of 0 because we didn't add it yet. But you can see here's the company that Instancio created. And you can see here we have lots of different test data pre-filled, company name, industry, headquarter, location. We have number of employees, and we have also a list of employees. So it also fills the nested objects for you. And the cool thing is also if you use JPA or something like that, you can also have it respect the validations that you define with annotations, which is pretty cool because you almost don't have to do anything to be able to define test data this way. And you can see the only, let's say, disadvantage in a way, or let's say difference to Data Faker is it doesn't, I mean, it also allows you to get more control over how data is generated, but it is obviously the most powerful if you can just leave it at the random, like default generation. You can also influence like certain things, but I wouldn't use Instancio if you have like very strict requirements on how you expect your test data to look like. But in most cases, this isn't really something you need anyways, because most of the time it's fine if the data is somewhat random, and maybe you could consider to do maybe one test with actual data if you actually had a bug or something like this. But yeah, usually this is kind of good, and also this was useful because we found out that we actually had some validations in place in the code that were wrong, because it generates random data, so sometimes it generates test data which is maybe longer or contains certain characters. Like my name is a very prominent example here. It has like a cedilla in it, and this cedilla often breaks certain applications. And you can figure out things like this because it always like randomly generates data for you. So yeah, this is a really cool tool I recommend you to use, so try that out for sure. And then let's see, so Mockito, I'm pretty sure, let's see, like who of you knows Mockito already? All right, so I'm not going to go into too much detail there. It's like a tool that you can use to, when you have multiple classes that you use together, to be able to mock certain classes. So if you want to test, for example, one class in isolation from others, you can do that. And if you're curious, have a look at the example in the code repository for yourself. So who of you knows mock server? Okay, a few of you, yeah. So the idea here is usually if, for example, I remember at the company we had a project where we had to call an external API to do some things. And the external API had some rate limiting in place on the one hand, and also every request cost some money. They had like a test endpoint you could use, but still, they still had the rate limiting in place. And if you would call the real API, then you would have the issue that it would sometimes fail because you may run into the rate limiting depending on how many times you call it, for example. Or also in general, it's not a good practice to use a real API, especially if it's like a external API that you're calling to test your code, because this way, if let's say the external API is down or they deployed some new version on the test environment and that breaks something, you don't have your tests all failing all the time. So mock server is a solution you can use for that. And the nice thing about it is mock server itself is also written in Java. So if you have a Java application, it is very easy to integrate. So let's have a look at that. So you can see we have a currency conversion client. That's a pattern I would recommend you to do anyways. So whenever you call a external API, I really recommend you to always put it in a separate class so that it is easily replaceable. So let's say you want to go to a different external API, you can then always just make changes in this class, and you might not have to do or just very small changes in the rest of the code. This way you can kind of decouple this. So you can see here I use the OpenER API, which allows us to do currency conversions. I get the conversion rate, and then I do some conversions and so on. And we have then the currency conversion service, which includes the currency conversion client that we pass in via dependency injection. And then with the method convert currency, we call the currency conversion client. So here, if I want to test this method, it would be quite difficult if I wouldn't be using something like mock server. One option you can do is you could use Mockito to simply mock this client here. But maybe you want to test more, in a more controlled way, what kind of responses it returns, or also you want to maybe see more easily why a test fails, because mock server also gives you quite a great output. Like it tells you, for example, if you made a request that it didn't expect, it tells you exactly what kind of a request it got and what parameters it had, and you can use that to then find out, like, maybe you defined a parameter wrong. This was actually a case in a production code that we were working on at another customer, where we had the case where actually one of the validations was also here set up incorrectly, and then this way the method wasn't even called in the first place. So here we have in the tests a class to test this. And it is actually quite easy to set up mock server. So you add the dependency in Gradle or Maven, for example, and then you can simply say extend with mock server extension. And then you can say here, for example, mock server upsert. And then if you have an openapi.json file, you can simply pass it in. And so let me ask, like, who of you knows what OpenAPI is, or like Swagger or something like that? Okay, that's awesome, most of you. So it's basically like a file where you can define how the API works. And you can usually generate this from your backend, which is what I would recommend you to do. Like, for example, Spring has support for that, and lots of other frameworks. You can actually generate the OpenAPI specification for you, so you can use it for the tests. And if you provide some example data in the openapi.json, then you can also have it be used automatically by mock server, which is kind of cool. So here I just pass it the path to the openapi.json file, I create my client, point it to localhost, and then I can call on mockserver.getPort. And this way I can essentially simulate the API that I'm calling. Lots of external APIs already have OpenAPI.json files they provide you anyways, so also make use of that. And then I can, for example, test here if my currency conversion works correctly. And you can see you can also define some other parameters here. This I just added to make it a bit more visible in the console to show you a bit better, but it's optional essentially. So let me run this and let's see what happens. And you see the test passed, and we can see that here it says we have here an HTTP request, which was get latest base currency. And you can see here I turned, of course, up the verbosity quite high, so you can see quite a lot. So you can see we have a GET request to this endpoint, and you can see all kinds of things that were passed in. And this really makes it easy, if a request somehow never reaches your backend, to troubleshoot this issue and find out what the issue is. And this way you can really do like an integration test without having the external API in this case, which is really useful. Okay. So let's go ahead. So who of you knows what parameterized tests are? Okay, that's like half of you. So I'm going to quickly get into it. So it's a way of testing that I really like. So this is like a very basic calculator example. It's probably something you have done like when you started to learn programming, like simply add two numbers up, or like a method to check if it's odd or not. And in JUnit, you can simply define add parameterized test instead of test. And then you can define multiple different ways. Like for example, here I added a value source, which allows you to define certain integers. Like here, I have different numbers, and then I have integer max value as well. And then every time, so then when I run this test, it will run this test with all of the different numbers here. And you can see also here in a nice output, which I really like, all of the different cases that were tested. Another big advantage of this is that if, for example, let's say you would write this in a different way, like you would traditionally do without parameterized tests, where you would have multiple different lines with the different values. Let's say it would fail at -1. You wouldn't know if 1, 3, 15, and so on would pass or not. And usually this is really useful. I mean, not in this simple case, right? But usually in your application, once you have more complex tests, it is very useful to know for troubleshooting the issue if it's only just one of the cases or like multiple cases that it affects essentially. And then there's also another way that you can do this, which is like CSV source, where you provide like values in a CSV format. You can also do that with a file. So this is very useful if, for example, you want to have your stakeholders provide you with some test data that you can use. So you can simply load in a CSV file that they provided you with, test data pre-filled, and then you can simply pass in the parameters here, and it will again call this, the same test with all of the different parameters that you can see here that we have. And also one neat thing I don't see many people do is you can specify the name here. So for example, with this curly brace index, you can specify the index of the test that is run. So this is index 0, 1, 2, and so on. And then curly bracket 0 is the first parameter, so int a, curly bracket 1 is the second parameter, and so on. And in this way, you can make it really nicely and visual when you run the test to see what kind of tests are being run. So you can see, it starts with 1, not with 0. And then you can see 0 plus 0 equals 0, and so on. And then if the test fails, you see exactly which issue or which case was the issue. And it allows you to easily debug it, which is really cool. And for the last way, you can define a method source, where you can simply define a method. Here you can pass a stream of arguments. I really recommend you to use this when you have more complex test data. So if you have simple test data, like here just, like integers, or like here just like basic strings or integers, something like that, a CSV source is good. But if you want to create like, let's say, very complex objects and so on, you can definitely do this very easily here. So use this approach for that. Good. So then who of you knows JUnit Pioneer? Almost nobody, or maybe one person. Cool. So that's also a tool I really like to use. So Pioneer is like an extension for JUnit. They have lots of different supporting methods that you can use, or like tools that you can use to make testing easier with JUnit. And one of them I particularly like is a feature called Cartesian testing. So I have here a implementation of a password generator. And by the way, maybe you should consider, like, this is just an example. If you're doing this in production, make sure your password generator is really secure. This should be reasonably secure, but just make sure that you check this. And you can see here we have an implementation of a password generator, and you can see we append here to the password different random characters we generate. And then if we want to test this method, it is kind of difficult to do with either parameterized testing or with just regular tests that you add, because you need to have a lot of cases. Where, by the way, with parameterized tests, the big advantage I see is people tend to, if you have a parameterized test, to be more willing to add new test cases. So probably you experienced this before, where you created a pull request, and then in your pull request, someone said, "Oh, can you add a case for this, please?" And you were like, "Oh no, now I need to, write a new test or whatever, copy the code." And then if you have a parameterized test, it's just as simple as duplicating a line, changing some values, and then you're usually done. And here, if I want to test this and want to make sure that it really tests all of the cases, one thing that the JUnit Pioneer allows me to do is this Cartesian test feature here. You can here define the different parameters you have. Like here I have the length of the password. Here I have if it contains alpha values, so like A to Z. If it contains numeric characters, uppercase, symbols. And then here I just defined true or false. And then what it basically does is it runs the test with all of the combinations that are possible between this. So the first one is maybe with a length of 8 without any, with all of these set to false, for example. And then the next one is with 8, but then let's say alpha set to true, and so on and so forth. And it executes this test with all of the different combinations that are possible. Here, I'm curious to know, who of you wrote tests before where you tried to test combinations like this, where you did this by hand by creating test cases? Okay, so that's half of you. Yeah. So this could be something you could use now, and it makes the maintenance a lot easier of your tests, because this way you just define it once, and then you can easily add new cases here. So for example, if your customer now says, "Oh, I want to, let's say, enforce a minimum length of 12 characters and a maximum of 20 or something like that," you can easily change this here, and it will automatically adapt the test. You don't have to write a ton more cases to test this. And then let's see what happens if we run this test. You can see, so it fails. And the nice thing is here as well, we have this nice output. So you can see here, I can also, with this notation, define different parameters that I pass in here. And I can see, so this one passes. But for example, here, the case where I have the length of 8, the alpha set to true, numeric to true, uppercase to true, and symbol set to false, then it doesn't work. Here it says, password, whatever this is, must contain numeric characters, and it doesn't. So what we have to do is we have to check out why is this test failing. So for the sake of time, I'm going to leave this out, but there is an intentional mistake here in this implementation. Maybe you can figure it out. All right. So then we are already nearing, I think, the time of the end. Let me show you one last thing, though, which I really like personally. So it's called ToxiProxy. I'm curious, who of you has heard of this before? Okay, it's a few of you. That's really cool. Who of those that raised their hand have seen my Fuji podcast interview? None of them. Okay, that's great, because I mentioned it there and I was curious if it was from there, but good. So it's a tool that allows you to do something which is called chaos testing, but more in a controlled way in this case. So, for example, we had a case at a customer where we noticed when I ran the application, suddenly the application crashed, and we figured out in the end that this was because the database was down momentarily, and apparently we had configured the application in some way that when it couldn't establish a connection to the database, it would throw an exception and quit the whole application. which was really bad, of course. So I wanted to make sure to write the test for this so that this doesn't happen again. And this is where I discovered toxic proxy, which allows you to test exactly for that. So one example here is I have here a setup of where I have a Redis container. So here we are using test containers as well, by the way. Who of you knows test containers? Okay, like half of you, I would say. So test containers is basically a tool that allows you to very easily spin up Docker containers when you're running a test. So this allows me to here spin up a regular Redis, for example, container here. And this is just like regular stuff from test containers. And then where toxic proxy comes in, as the name suggests, it's kind of a proxy to your, to your database, for example, that you can use. And basically, you point it to your Redis container, and instead of making the requests to the Redis container, you're making the requests or whatever calls you make to the toxic proxy container, which then relays the traffic to the Redis container, but it does so in a way that you can manipulate really easily. So here you can see, for example, you just create a new toxic proxy client in the setup, create a proxy to the Redis, and then we connect Redis, which is like a Java implementation to query Redis here. And then you can set some initial data like we do here just to use for the test. And there are different things you can do. Like, for example, here there is where we introduce latency and jitter. So, for example, if you want to see like how does the application behave if I introduce latency, so like each request takes longer than you would normally have. And here we can say there are like toxics, which is like a list of things that you add that are kind of toxic in a way, like, for example, you make the connection slower or something like that. And you can add multiple. Here I just added latency and jitter that I set to a defined value. Then if I call redis.get, this will go to our Redis container, or in this case, first to toxic proxy, of course, which will then relay the requests to Redis, but it will do so in a delayed fashion and with some jitter. And then we check if we get the value properly. And we can also have a test here, for example, we cut the connection completely, which is kind of the test that we had in our case at the customers, at least similarly to this. So we can say cut connection downstream and upstream. You can also define, for example, that only certain amounts of connections are cut. Like, for example, you can say like every third connection is cut with this rate here. And you can define if you want to do this for both down and up, or just one of them. So like if it's about the connection from, or like a request to, for example, the container, or from the container back. And then we can say here, assert that. And then again, we can say like here, catch throwable, where we say we expect it, for example, to fail. Like, this could be the expected behavior. This depends on what you expect in your application. But you can see like if the connection is cut, here in this case, when we call redis.get, we expect it to then fail. And you can see here, when we then restore the connection, so we remove the toxics that we added earlier, we check that if we call redis.get again with the same key, if then the container works again after we reestablish the connection. So let's just run this test as well. And you can see it was a bit quick, but we tested here successfully if it was working. Just to prove it to you, if I now, let's say, comment out these two lines, and then I try to run the test again. You can see it takes already longer, which is a good sign in this case. I never test a test case that I've never seen fail before, so let's make the check. And you can see the build failed. And I can see here an assertion error on this line. And we can see, if we go to 87, that you can see here we didn't get the result that it failed with the Redis connection exception, because, of course, the connection wasn't cut, obviously, right? So this is a very powerful tool you can use to test like the case that I mentioned, where, for example, either the connection is like intermittent to your database or to some other dependency you have, and very easily test this. And this allows you to make sure that even if you do changes in your application, that you still have the benefits of having the test make sure that it still behaves the way you expect it to. And this is really useful for that. So I think I'm nearing the end, so I'm going to go ahead and look if we have some questions already. Oh, that's cool. We have some questions. So I'll focus on the questions for now. Thank you so much, by the way, for asking so many questions and being here to the last session. So let's have a look. So how do you make test cases deterministic with Faker, assuming you don't want random data with every test? Okay, good. So while I'm answering this question, I'm going to show once again the QR codes, just so you can scan it again in case you would like to ask questions as well, or like want to get the code again. So I would say if you want to have the test data be deterministic, I think you have to ask yourself at this point, is it really necessary that I do this? Because usually it is, sorry?
Yes,
for debugging. So yes, that's actually a good point that you bring this up. I didn't mention this, but the cool thing is with DataFaker and Instancio is when you have a test that is failing, it prints the seed in the console, and you can simply copy that seed, and then you can define it in a config, and then it will use this seed and will lead to reproducible failures. I just realized, I think that was probably what you were asking about, right? Perfect, yeah. So that's exactly what I really love about this tool. So like if it fails on CI, for example, for some reason, because you have some test data you didn't expect, then this makes it really easy to reproduce this. You just copy paste the seed, set it through the config. You can find this in the documentation from DataFaker and Instancio, and then you can easily reproduce the test. Right, I hope the question is answered this way. Great, thank you so much. But great question, yeah. Good, so then does DataFaker support internationalization, e.g. different formats for full addresses? That is actually a good question. I never had a look at that. We could have a quick look to see if that is the case. I'm not sure. But yeah, let's see. So we have here full address. Let's see, if we call address here, do we have a way of specifying it? Oh. Let's see. Maybe, but I think I would expect it on the address, but I'll check it like this first. So I can't really see it here. Let's try the next thing that was suggested. Thank you. So let's see. So there are quite a lot of things, but let's see if we have I18 and internationalization. No. So I'm not sure, to be honest. Look it up in the documentation, I would say. I'm sorry that I don't have a better answer. You can also feel free to approach me afterwards, and we can have a look together if you want. That's a good question, actually, by the way. Yeah. Thank you for that. Good. So let's see. So what happens if the checker callback innovatility runs longer than the at most time? So you mean like if the check that you perform in innovatility is the one that runs longer? Is that correct? Okay, so then you have to account for that in your timeout that you define. So you have to make sure that you define a timeout that is long enough. Like if you know, for example, the request that you're making, for example, it takes a long time in the callback, that you have your timeout long enough that it is able to be executed a few times at least. So like, let's say you know that your call takes 5 seconds, then you should make sure to, for example, set the timeout to 30 seconds or so. And of course, availability will simply wait when making the call, and then it will constantly retry after the last retry to see if it passes. And this way you can still see if it works or not. But yeah, this is something you can't really avoid in any other way, of course, except for finding a different way to do the assertion, for example, where it doesn't require you to wait for a long time or so. I don't, did that answer the question? I assume it's a yes, else let me know. Okay, is there a way to ensure that our tests always use assert_j? This is for enforcing standard and quality. Yeah, there is actually. You can use ArchUnit to do this. If you've never heard about ArchUnit before, definitely make sure to look it up. It's a library that is really useful. You can use it to test like your architecture. Like for example, you could also test if, for example, in a Spring Boot application, if you consistently use auto-wired instead of defining constructors, for example, you can define all kinds of rules. And there were also, I think, some other talks at this conference, which you can, watch as soon as the recording is available, or like on the internet. There are quite a lot of talks you should be able to find where you have different like talks that explain how to use it. But you could set it up to say like that you expect every assertion to be assert that, for example, which would be quite easy. And then, you can enforce it this way. I hope I was able to answer the question this way. Okay, good. Do you have any recommendations for tools when you're developing property-based tests? Yes, there is actually a tool for Java. I have to say I forgot the name of that, but there is one. So if you Google if you Google property-based testing Java, you should be able to find it pretty quickly, and it's a pretty cool tool. What I showed you with this Cartesian test kind of, goes in the direction of property-based testing, but this other tool is even better. And I was actually considering to add it to the examples. Definitely check that tool out. It's really good. And I would say, there are other tools for other programming languages as well, by the way. You just have to, look for them. But in terms of the implementations, I feel like the ones that were made, was made for Java, this one is, in my opinion, the best of all of the options that are available. And then what is the advantage of another library, Pioneer, if you could simply do it with plain method source? So maybe I didn't explain it clear enough what the advantages are here. So it's a bit different here, I would say. If you look at this here, you can see we have the values and so on that we define in a generic format. Like we say, we want to have integers that have a length between 8 and 12, for example, or like a Boolean true, false, and so on. And you could do this, of course, as well with a parameterized test. But then once you define these as parameters, you have to then write like a single line for each combination that you have. Like you can see here in parameterized, if you go to the test, we have here the different lines where we have the combinations. So let's say you want to test all of the combinations of 0 and 1. You have to essentially write these 3 lines just to test these 2 values and all of the combinations of those values. And what the Pioneer does for you is you just need to define in a generic way what kind of parameters you expect, and then it automatically generates all combinations for you. So you can see if I run this, you can see it tested 32 different combinations. So you would need to write those 32 combinations yourself, which is not really maintainable, because as soon as, let's say, you don't want to limit it to these cases. Let's say your customer comes and says like, we want to enforce that you use at least one special character of this type, like, a dot or a dash, for example. Then you would need to add like, like 60, you would have to add like 42 more tests and extend the existing 32 tests. And that's a big pain. And, probably you won't do it because it's such a big pain. And Pioneer really makes this painless for you, because you can simply add one more line here, change the test case a slight little bit, and then you're done. And it's also a lot easier to read, because if you have like, let's say 42 test cases, one after another, people don't instantly know by looking at the test cases if they are testing all combinations or not. You could be maybe missing one because you forgot to add one, or someone during the review didn't spot it. This could really easily happen, and this is something you can prevent with that. I hope I was able to explain the advantages a bit better here. Is this good? Thank you. Let's have a look. Why would you like to use the Cartesian test? I.e., in the example given, you could just write a check. If parameter is true, the corresponding symbol is there. I'm sorry, I don't really understand the question. Could the person that asked this question maybe elaborate a bit? Or maybe it already cleared itself with the previous answer. If not, please give me a bit more details and ask again, and or come after the talk and we can have a look together. So we've seen that Instancio generates random strings. Does DataFaker generate more real data first names? Yes. Actually, let me show you this really quickly. So if I go here to DataFaker and we go into our test, and I can again add a breakpoint and run it in debug mode, and then we can look at how it looks like. And you can see here, since I defined, for example, I want an ID. Of course, this is just a generic format. If you want a specific one, you need to define exactly what format you're looking for. But for example, the company name looks somewhat legit, right? It's Johnston Moore Industries Machinery. Headquarters location is something that seems like it could be real, right? So this is really useful for that. And if you remember, with Instancio, we had really random test data. You can see here, like we have like position developer, manager, supervisor. So really, you get a lot of different things, like also the salaries, like in a range that kind of makes sense. Yeah. So I hope that question is answered this way. Is it good? Thank you. Let's see. So I think we should have time for 1 or 2 more questions. So do you have any tool suggestion to use if my expected output is a 100-line JSON which differs from actual with just one value? It's quite hard to find the diff. Good. That's a good question. What I usually do in these cases is, for example, I either, it depends kind of what is more convenient. I define it, like, especially with the newer Java versions where you can have like a multi-line block text. I define it either in the test or I define it in a file, and then I read in this file. And then I use a library like JSON or something like that to deserialize this JSON. And then I just deserialize it 2 times. And then in the second one, I change the line that I want to have changed. And this way, it's really easy to see, because when you look at the test code, then you see that you read the file in, for example, you decode it with JSON, for example, to a object, and then you set a different, one line, for example, to a different value, and then you see exactly which value changed. And this way, it's really easy. You don't have to do a diff at all, and then you can use it this way. I hope I was able to answer the question. Good. Okay. I think I'm already at the end. Thank you so much for asking so many nice questions. If you want to have them answered, feel free to approach me afterwards, just so that the next person could already prepare here. And thank you so much for the attention. And also, I would like to thank all of the organizers and helpers of JCon that make it possible. I think that really deserves a big round of applause.